Good day. Today we can discuss the problem about a linear elastic spring is subjected to a force of 100 Newton as shown in this figure. Okay, calculate the displacement and the potential energy of the spring. So the given data are force F is equal to 1000 Newton and stiffness, the spring stiffness K is equal to 500 Newton per meter. And in problem they are asked about calculate the displacement and the potential energy with the Rayleigh-Ritz method. So these are all the questions. From the Rayleigh-Ritz method we should identify total potential energy. The total potential energy can be determined from the formula of phi is equal to U minus H. Here U is strain energy, H is the external force acted on the structure. So this problem we considered about the spring. So what is the spring's strain energy formula? The strain energy of a spring can be determined through the formula of 1 by 2 kx into x. This is the formula for identification of strain energy. And what about H? H is generally known as work done by external force, work done by external forces, work done by external forces. So the formula here you see the spring has force F. Due to the force applied, the spring has some displacement. So the work done by external force is F into x, which is the formula for work done by external forces. So from this we can substitute this U value and the Fx value, I mean work done value, on the given total potential energy equation. So the equation which can be written as like phi is equal to U minus H, which can be solved as like U already we found of into kx into x, and also then work done minus H. So work done, the formula is Fx, so which can be written as like minus Fx. First, initially we consider the spring is in stationary position, so that total potential energy can be written as like 2 phi divided by dou x is equal to 0. So already we find the phi value here, okay, of kx into x minus fx. Here if I differentiate this phi equation with respect to x, means I got of 1 by 2 into the kx. If I consider this x, I differentiate this x with respect to x, means I get 1. So I won't write here 1. So minus fx. Here also 1x is available. If I differentiate this fx with respect to x, means I can get the 1 for x. So here minus f. Okay. Finally, the equation can be written as like kx minus f is equal to 0, because the 1 by 2 does not is equal to 0. So I can remove, but the equation is kx minus f is equal to 0. Already in problem we are having stiffness value k and f value force. Okay, so we can substitute the k and the f value on the formulated equation. From this we can get 500 x minus 1000 is equal to 0. If I simplify the term, I can get, I mean here 500, okay, sorry, 500 x is equal to 1000. So x is equal to 1000 divided by 500, which is equal to 2 mm, which is the displacement I got from the total potential energy equation. And the stationary position equation from differentiate the total energy function with respect to x. After that, we can substitute this identified x value into the initial phi equation. From this we can get the total potential energy. Okay, let's see how can we solve the problem. For the reason, I rub the board and then I can move the next step. Already we know the strain energy, which is calculated from u minus h, the of kx square minus fx already we got. So that in this equation we can substitute the x value. From this we can get the answer. What is the total potential energy? Let's see. Now I can return the equation total potential energy phi is equal to 1 by 2 kx square minus fx. The k, according to our problem, k value is 500. The x value I got from the previous step, displacement is 2 mm, so kx into 2 square minus what about f? In problem we are having the force is 1000 and x is the displacement, so x I got 2. Okay, from this if I solve the total steps I can get the total potential energy, which can be written as like minus 1000 Newton. Likewise I got from the equation Newton millimeter, which is the total potential energy we got from the spring problem. So the questions are displacement and total potential energy. So the displacement from the problem x is equal to 2 mm. After that, potential energy of the spring according to the given problem is phi is equal to minus 1000 Newton millimeter, which is the answer for the given problem. Thank you. For having any doubts, you may ask me through comment box.